All right, we'll be taking another look at some piecewise graphs today and some properties of them. Our goal today is to take a graph that's already been graphed for you that happens to be a piecewise graph and come up with the equation for it, and then work a little bit more on analyzing some of the properties that we talked about in the last lesson. So this first graph here is a piecewise function. You can see that it has two parts to it, and we are going to come up with an equation for each part and talk about what its domain and range will be. All right, so first of all, we are going to talk about this part right here, okay? We're going to talk about this line right here. So clearly it's a line, excuse me. If we want to be able to make up an equation for that line, we need to know two things. We need to know its slope and we need to know its y-intercept. This f of x serves basically as the y equals piece of this, and we need to come up with the other parts to it, okay? So we need to come up with the mx plus b part of it. And if we look at our slope, we can see that it goes up one, right one, up one, right one. And so our slope would be 1 because that's what's happening. So our slope will be 1x. You don't need to write the 1 in front. Plus our y-intercept. And although there is an open hole here, if this line were to continue like this, it would cross the y-axis at 0, okay? And so our y-intercept is 0, so technically this has a 1 in front of here and then a plus 0 behind here, but you don't need to write the plus 0 and you don't need to write that dotted line in front, okay? Now, the trick is that that line doesn't exist on the graph, on the entire graph. So what we need to do is we need to put kind of a comma here, and we need to tell people that would be looking at this for which x values does this exist. So you want to kind of analyze what's happening. Right here, my x value is -1. Here, my x value is -2. Here, my x value or my left-right value is -2. Here, my x value is 0. Although it doesn't exist there, it exists really close to 0. So basically, every x value on this line is to the left of this key point right there, which is 0. And that 0 is not included, so you're not going to underline it. If it was colored in, you would underline it and then be 0. So basically, this is saying y equals x as long as the x values are less than 0. Okay? And then we're going to do the other part, which would be this part right here. This happens to be a horizontal line, and horizontal lines always have the equation y equals, and you've already got the y equals part in there. And so in this case, all of your y values are being held constant at 2. And then you need to say, what x values does that line exist for? Well, my magic number right here, my magic x value is 0. Here my x value is 1, my x value is 2, my x value is 3, my x value is 4, on and on and on, and anything in between, okay? So basically that line exists whenever my x values are greater than or equal to 0. And again, you always describe those with your x values, not your y values, your x values. This line exists when my x values are 0 or bigger, okay? Just a quick little review here. Does this graph have any points of discontinuity? That's places where you would have to lift up your pencil, just to remind you. And yes, it does. Right here, this is the spot where I would have to lift up my pencil, and that's at x equals 0. All right, a couple other ones here. And when we list these functions, we typically list them from each piece from left to right. So I am going to first of all start with this piece right here. I want to get it into y equals mx plus b form. Okay, and so I've got kind of the y equals piece right here, and I want to do the mx plus b. So you want to first of all look at its slope. It looks like it goes down 1 and right 3. So my slope would be -1/3. And my y-intercept, although it doesn't cross it, if it were to, I would go down 1 and right 3. If that line were to continue, it would cross right here at a y-intercept of -1, 2, 3. So my y-intercept there would be -3, okay? If you can't exactly quite figure out like that from a graph, what you might need to do is literally pick 2 points that are on this line. So for instance, this would be the point -6, -1, and this would be the point -3, -2. And then you could find the slope that way if you wanted, and then follow the y minus y1 equals m times x minus x1, and simplify it that way also. If that is easier for you, that method would work also. Okay, then I need to tell people what x values that exists for. So sort of my magic spot right here where it ends is right there where my x value is -3. Okay, and it's not exactly -3, so I won't underline it, but it is close to -3. And then all of these x values going this direction are less than -3. X value of -4, -5, -6, -7, they're all less than -3. So this would be x is less than -3. Okay, then we're going to go ahead and go to this piece in here. And again, this is a horizontal line. They always have equations y equals just some number. In this case, my y values are being held constant at 4. And that exists when my x values, I have one magic spot here at an x value of -3 and one magic spot here at an x value of 2. So here my x values are basically between -3, notice it's underlined because at -3 it's a closed circle, and 2, which I'm not going to underline because at 2 it's a open circle. Okay, and then we have this last piece right here, which we need to kind of analyze. And here we can see that our slope would be rise of 3, run of 2. So up 3, right 2 would be our slope. So 3/2 x. And then if I go down 3, if I go the opposite direction and go down 3 and left 2, this is where that line would continue. And my y-intercept, if it would continue, would be right here at -4. Okay, and then I need to say which x values that little section exists for. So my magic spot right here is when my x value is 2. And then all of these x values are to the right of that spot. So all of those x values would be bigger than 2. So x is greater than or equal to 2. Okay. And then I want to know at what interval is the function increasing, decreasing, or constant. So it's increasing when it has positive slope. Okay. This is the section where it has positive slope right here. And that exists, again, we already figured that out, when x was greater than or equal to 2, or greater than or equal to 2. That is in interval notation. And then if we were to write that in set notation, it would look like this. Okay. Decreasing is where it has negative slope. So that's this black section in here, negative slope. And that negative slope happens up here when x is less than -3. So this is interval notation. And this would be set notation. And then it's constant in the green part. And it is constant when x is, I should do this. It is constant in interval notation between -3 and 2. And in set notation, it would look like this. All right. One more, this is the same graph that we just got done looking at. And now we want to look at what the domain and the range is. And remember, to do the domain, you're going to draw a vertical line and you're going to move it across and you're going to see where the graph is touching. So as I move it across, my graph is, it's touching the graph because that line, red line continues over there. It touches, it touches, it touches. Right here, it's still touching the graph at that closed circle. And it's touching, 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 touching. Right here, it touches because of the closed circle. And it keeps touching as I move to the right, all the way around. Okay, so my domain in set notation would look like this. Every number, and in interval notation, it would go from negative infinity to positive infinity. Okay, now your range, you're going to draw a horizontal line, and you're going to drag that across, and you're going to see where it touches. So as I draw a horizontal line and I drag it, right down here, I'm not touching the graph. I'm not touching it, I'm not touching it, I'm not touching it. I start to touch it here really close to -2, not quite at exactly -2. Remember your range, you're looking at your y values now. So right here, my y value is really close to -2. And then I'm touching, 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 touching. Still touching, even way the heck up here I'm touching because that line continues. And so my magic spot is that I start touching it at -2 and above. So it would be y is greater than -2, not underlined because it's not a closed circle. Okay? And then in set notation, it would look like this. Sorry, I did set notation. In interval notation, it would look like this. Okay? All right. Then this says determine the range of the function if I've given you the function and the domain is this. So there's a couple different ways you can do it. Some key things you need to remember. Your domain is your x values. Your range is your y values. So basically what's happening is I've given you your x values and I want you to find your y values. Couple ways you can do that. One thing you can do is you can kind of think about making a table. My x values are -2, 0, and 7. So you can plug those into the equation and figure out your y value. So when x is -2, I can go 2 times -2 minus 1 by plugging it into this function right here. 2 times -2 is -4, minus 1 is -5. And I could continue that process, or I could go to the graph and go, okay, when x is 0, so when x is 0, what's my y value? Here's my coordinate where x is 0, and my y value is -1. Okay, when x is 7, my y value is actually off the graph. It would be up here somewhere. So I'm going to plug that in. So 2 times 7 minus 1 would be 13. Okay, and so your range, if we kind of list that, your range would be -5, -1, and 13. Okay, and similarly, the other way around, this time, if I give you the range, these are now your y values. Okay, and you have to determine the domain, which is your x values. Okay, again, you can think about it as a table if you want. Your y values are -5 and 2, and you could plug those in to figure out what your x values are. Notice you don't have any y, but f of x can be considered y. Okay, and so I would go -5 equals 2x minus 1. If I wanted to plug it in, add 1. -4 equals 2x. And so x is -2. And you can also see that from the graph. And that one's actually off the graph. But on the next one, if your y value is 2, here's where my y value is 2. Nope, that's not right. My y value is 2 right here. Okay? And I need to figure out what my x value is. So when I plug that in, my y value is 2. I'm going to go like this. 2 equals 2x minus 1, add 1. 3 equals 2x, divide by 2, and x is 3/2, or 1 1/2. okay? Which you can kind of see from the graph too, except for we would be estimating that. Okay, so my domain, your domain is your x values, which are these right here. All right, and that should do it for this lesson.